Hello, everyone. This is Charlie. This is the podcast to Hell and Back. And it's April 9th. I'm at my home. I'm recovering from being in Massachusetts General Hospital 2 days ago for a procedure called an ablation of atrial fibrillation. So let me explain that for 1 second and then what I'm doing about the podcast today, because it's related to heart. So this was a condition in my heart. I think it's been going on for 2 or 3 years, though I didn't understand that. That's why I was getting some symptoms until recently. I was getting symptoms of being dizzy, being weak sometimes, and feeling like I was going to fall down. And then I did fall down a couple of times. And my doctor wasn't able to diagnose accurately what the problem was until one day I was checked at a doctor's office, and instead of my usual heart rate of 60, it was 130. So I had that checked out, and eventually they did what's called a Holter monitor, where I had to have a device that kept my heart rate for gosh, I forget how long, for a week or so. And it turns out that 20% of the time I was in atrial fibrillation. Here's what that means. Usually, with a normal heart, and from the time that you're born or before you're born, you generate your heartbeat in one spot in the heart, which is in the right, a certain spot in the right atrium, one of the four chambers of the heart. And it's a certain spot there called the sinus node or the sinoatrial node. And that's where your heartbeat starts. And then it sends impulses out to the whole heart. And then the heart beats all together. But it starts there. You've got one place that's always the leader, unless you have atrial fibrillation. And when you get atrial fibrillation, uh, for one reason or another, and I don't know what the reason is in my case, there's a variety of other spots in the heart that can start heartbeats independently of the sinus node. And then you've got like a competition going on. Heartbeats are coming from different places in the heart. So it's a less efficient heartbeat. It confuses the heart, and you get these rapid and then very slow heart rates. So it's erratic. Um, Fortunately, they discovered that before anything bad happened, and they took me in to Mass General, and they did a procedure called ablation. And what they do with that is they thread a catheter up through from your groin, through your blood vessels, into your heart. And with that catheter, they're capable of destroying or ablating these very spots in the heart that are generating the mm, abnormal or the wrong heartbeats. So you ablate those areas that are doing that, which then allows your sinus node to once again be completely in charge. And then you have normal heartbeats. And hopefully that's going to be the case with me. I won't know for another 2 or 3 months whether this has worked really well, but it works apparently in about 85% of the time. So that's the backstory. That's the front story and the backstory. I'm recovering from that now. And this brought to mind something from, oh, when I was in college 57 years ago, a little research project I did that I was very intensely into at the time, having to do with heartbeats. So I just thought it would be a convenient time to go back and read what a few years ago I wrote about that experience of doing that research and what I come to in that. And I think it may sound to you just like maybe it's a heart related thing, but you'll see it's not just related to heartbeats. I hope you'll find it interesting. Let me see if I can find it. I have to share the screen. Um, mhm. Here it is. Okay. Let's see, am I still recording? I can't tell. Huh. Yeah, I am. Okay. Sorry about that. Here we go. I became aware during college that I was drawn to remoteness amidst gatherings of people and self-imposed deprivation amidst plenty. So it was not as unusual as it may sound. For nearly a week during one Thanksgiving break, I confined myself alone to the depths of the university's catacomb-like biological laboratories, where almost the only living things were in crates, cages, jars, bowls, and petri dishes. As if camping, I arrived with food, drink, a sleeping bag, my guitar, my diary, and a book to read if I needed a break from my singular focus, a research project for a biology class. Though I hardly knew it at the time, the motivations to spend my first ever Thanksgiving alone were as much personal as academic. I was studying interdependency, connection, and communication within a biological system, while personally I was on retreat from other humans, communicating with no one. I wanted to answer a question. How can all of the 2 billion separate heart muscle cells of the human heart, each one having the inherent capacity to beat at its own pace, beat together like members of a synchronized swim team swimming together, unerringly from birth to death? Each cell has its own complex inner world with its own complete set of DNA and multiple magnificent molecular machines contained within a sophisticated semi-permeable membrane, allowing just the right things to pass through from outside to inside and from inside to outside. How could so many separate cellular beings beat as one, propelling blood throughout the body, sustaining life? How did each one know when to beat? If they didn't beat together, it would be fatal. A specialized collection of cells at the top of the right atrium, known as the sinus node or the sinoatrial node, functions like the coxswain of a crew boat in a race, setting the pace for all muscle cells to beat as one, delicately reflecting the range of bodily needs coming to it from the sympathetic and parasympathetic nervous systems, from hormones and other chemical influences. These nodal cells have the capacity to initiate an action potential 40 to 100 times per minute, which spreads like an electrical impulse coursing along electrical wires across specialized conducting channels in the wall of the atrial chambers. Within a fraction of a second, that action potential arrives at a second specialized cell collection, the atrial ventricular node, which serves as a relay station, sending the impulse along similar conducting channels in the walls of the ventricles. Such is the electrical conducting system in the heart. The mechanism for sending an action impulse from cell to cell along a pathway is not dissimilar from the way action potentials pass from one neuron to the next, and is therefore not that puzzling. An action potential results from an asymmetrical distribution of positive and negative ions, which are small molecules with either positive or negative charges, across a cell membrane, which creates a very small but measurable electromagnetic charge in a process known as depolarization. The membrane of that cell suddenly allows ions to pass through. The ions rush in directions through the membrane that equalizes the charge between inside and outside the cell. The changes external to the cell membrane immediately impacts the membrane of the next cell, leading to depolarization of that one. Very rapidly, a wave of depolarization takes place from cell to cell along the specialized conducting channels. Much more puzzling, at least back in 1969 when I was doing the project, was that the impulses not only traveled down these channels, but also spread like a wave across the entire, the entire heart muscle. While the vast majority of heart muscle cells were not adjacent to the specialized conducting channels, still they would beat in sync with all other cells at the pace set by the sinus node. When the membrane of a cell depolarized, the flow of ions would change the internal milieu of the cell, causing the cell to contract through changes in the microtubular skeleton of the cell. But how could each cell know when to beat? How did the message get communicated across the heart so quickly, allowing so many to act as one? Could I find structures within the cell membranes that would facilitate such a wave? That was my question. For those 6 days, the only human I saw was a security officer who walked the halls once in the morning and once at night. He was aware of me, and we never spoke. I was alone with some live frog embryos that had been left for me by my professor. My strategic plan, while I knew it would be technically challenging, was clear to me. What I did not expect was the sense of foreboding that gripped me at different times of day and night. I felt as if something bad were about to happen. I tried to ward off the unnamed demons by talking out loud, singing to myself, taking brief walks down the hallways, soothing myself. Charlie, don't worry, there's nothing weird going on here, it's just your imagination. I couldn't eliminate the sense that it was spooky to spend days and nights without human contact amidst long, dark corridors, watched over by collections of dead and live biological specimens. I began to dissect the frogs that were left for me. When I separated the hearts from the brains, the hearts continued to beat. When I severed connections to the rest of the body, still the beats continued. The hearts had lives of their own, living in life-sustaining soups in petri dishes, pumping away even though divorced from anything to pump. With a scalpel, next I cut each heart into small pieces of heart tissue, each piece still beating, but not necessarily at the same pace as other pieces. Then I cut each piece into smaller pieces. Still, they kept beating, the way that members of an orchestra, separated from the whole, might reassemble themselves to play in quartets and trios. As I cut the pieces smaller and smaller, inevitably, a point would come when the beating would stop. The heart cells would stop. At some moment, impossible to determine exactly when, the music would end. Life would stop as a result of my cutting. My technical challenge was to cut the hearts into clusters of cells that were as small as possible, but still beating. When I was spooked, I felt eerily as if I were playing God with frog embryo hearts, that it was wrong to do so and that there would be consequences. This went on for about 3 days, perhaps longer, I can't tell. Every step forward followed dozens of missteps in a process of trial and error. My patience and tolerance were seriously tested. After innumerable trials, I was able to predict at what point in cutting the tissue into smaller and smaller pieces the cells would stop beating. I learned to stop cutting just this side of the life and death line, and then count the number of cells remaining in the cluster using a microscope. Finally, I isolated several tissue clusters with fewer than 25 cells each, maintaining their beats. I was glad to have arrived at the end of the technical challenge by then, since my irrational mind had again fallen prey to dark and eerie forces. For instance, a few times after cutting and cutting, I pictured pieces of tissue, clusters of dead cells, all emerging from the carnage, joining together, zombie cell clusters attacking me from all sides. I deliberately interrupted the troubling images, shining the light of reality on them, but I couldn't deny that paranoia had crept in. It troubled me to think that if the dead cell clusters smothered me to death, no one would ever know what happened. I bathed the tiniest, still beating clusters in liquid nitrogen, freezing them instantaneously, stopping all cellular activity while preserving cellular structure and membrane integrity to the degree possible. Finally, I had several frozen clusters. In the next step, known as freeze fracturing, which would have to wait until school was back in session, I would gently but firmly strike the frozen clusters with a small tool called a microtome, causing the frozen clusters to fracture. Done correctly, the fractures would occur along predictable plane between cell membranes, so that on one side I would find the outer surfaces of some cell membranes, and on the other side the outer surfaces of cell membranes that had been adjacent to the first ones. As I ended my most bizarre Thanksgiving ever, I emerged from the long, dark hallways back into the light, clutching my precious frozen tissue samples. I was glad to leave the dark, dreamlike world in which tiny heart cells were superior beings capable of extraordinary capacities, that I was a Godzilla playing with their lives, and that in the interest of scientific technique, I was destroying their communities. As school resumed, I took my treasure to the medical school, where, with the help of a professor and a technician, I freeze fractured the clusters into smaller clusters. As hoped, the samples did fracture along the planes of the cell membranes. We could view the outer surfaces of the membranes under the extraordinary power of the electron microscope, which appeared like the surface of the moon, with bumps and valleys, clumps and tiny structures. We could look at the cell membranes of two adjacent cells, which had been juxtaposed, and we could see where the configurations on one cell membrane matched up with corresponding ones on another membrane. It was amazing. And we recognized that among the structures on the membranes were a multitude of well-defined tiny holes, large enough to allow small molecules to pass through, but small enough to block larger molecules or organelles from leaving or entering the cell. These holes turned out to be gap junctions, discovered in research in that same era, well-constructed channels that linked the inside of one cell to the inside of another, the perfect candidates for structures that could allow small ions like potassium, calcium, and sodium to pass through with almost no resistance, depolarizing the cell membranes, which would cause the cell to contract. Suddenly, a new concept took hold in my mind. If the wave of depolarization could happen within the same second across the entire heart, opening up all gap junctions of all heart muscle cell membranes almost simultaneously, allowing the flow of ions all nearly at the same time, all driven by the beat of the sinus node, it was imaginable to have 2 billion cells act in sync. In fact, the 2 billion independent cells, by opening the windows between them throughout the heart, all at the same time, would functionally convert 2 billion small independent chambers into one big cooperative one. The contractile potential of all 2 billion could be activated at nearly the same time. Now, when I wrote this, I wrote, "It's been almost 50 years. The memory of those days remains vivid. The excitement of the investigation, the challenge of isolating a living cluster of cells, the thrill of succeeding, and the paranoid halo that came and went. But the most lasting legacy of this project for me is my respect, even love, for the miraculous lives of cells. A cell membrane surrounds, protects, and supports the complex inner world of the cell, a world with dozens of complex structures perfectly adapted to carry out dozens upon dozens of activities, hundreds, perhaps thousands of different types of molecules, always moving, always transforming, and playing their parts in the intricate cellular world, and processes of energy production, genetic transcription, protein construction, waste removal, nutrient ingestion, and more. To think that something so small could be so complex and so beautifully organized for the ultimate purpose, the heartbeat that sustains us, is incredible. And that cell, each of those cells, lives in a huge neighborhood of cells, crowding each other like apartments in a giant apartment building. Molecules flow between and among the cells through a variety of specially constructed openings, through both active and passive transport in both directions. The life of a cell carries lessons. Number one, this is a living entity that has a clearly defined purpose, which justifies the multitude of operations going on inside and around it. It all makes sense, far more so than often seems to be the case with our lives. The suggestion, as I see it, is that regardless of the nature of my current purpose, I am functioning at my best when I'm attuned to processes around and beyond me, finding my purposes there. Number two, the cell is so busy and conducts it all with such amazing balance. What is taken in must be balanced with what is put out. What is consumed by the constant activity of the cell has to be replaced by nutrients and oxygen. The cell lives with rhythms, balancing activity and rest, energy output with recovery and replenishment, attending to the inner life while maintaining awareness and responsiveness to the outer world. Number three, as I see it, the cell is a model of willingness to do just what is needed, humility in playing a small part in a large world, and model of sustainability in constantly recycling just the right amounts and types of matter and energy to stay alive and fresh. If I am adrift or preoccupied, I can sometimes think about the life of a cell, which moves me toward purpose, willingness, humility, balance, rhythm, flow, and the kind of sustainability that comes from maintaining my inner self and the world around me with which I am interdependent. Perhaps the deepest lesson I take from the life of a cell is the capacity to be both independent and interdependent. The cell, as a distinct entity boundaried by a cell membrane, is made up entirely of elements that come from outside itself. Even the central identity of the cell, as stored in the DNA in the nucleus, is the same DNA double helix to be found in all other cells. In this respect, the cell has no uniqueness, no true separateness, any more than one wave in the ocean is separate from all other waves. The cell is entirely a recycling operation, carrying out its assigned purpose. Similarly, the concept that there is a boundary around the cell turns out to be an illusion. There is a semi-permeable membrane made up of elements that are constantly turning over and that allow things to move in and out so that the heart cells, the 2 billion of them, can act as one. In one sense, there are 2 billion cells. In another sense, there is one. When I personally allow myself to see that I am made up entirely of circulating stuff from the rest of the universe, and that there is no unique Charlie Swenson substance inside, that I represent a constant recycling operation, and that there is no true boundary around me. I am in constant exchange with the world around me to a degree far beyond my usual notions. I try to relax into this level of truth. I feel more relaxed, more joined with what is around me, and energized. It automatically creates in me a greater sense of synchrony and responsibility with and for the rest of the world. I can never accomplish this to the degree that a cell can do it without even trying, but I still find it helpful to have a hero to look up to. In 1980, when I visited China with a group of 25 other Americans before the modernization of that country, I remember waking up early in my hotel in Beijing. Looking out the window at about 6:15 a.m., I saw hundreds of people gathered in a large open space. They were practicing the ancient art of Tai Chi, and they were silently moving in complete synchrony with one another. Hundreds became thousands as individuals and families from every generation arrived, joining in the same movements and with the same rhythm. Each person was like a heart muscle cell, separate and complicated. Without missing a beat and without hesitation, they synchronized with each other, creating something much larger and more powerful than any one of them. At 7 a.m., a horn sounded in the city, and within seconds they were all on their way, most on bicycles, others on foot. It can be reassuring to realize that each of us is breathing in, breathing out, opening up, closing down, eating, fasting, sleeping, then being awake, acting in harmony, acting in conflict, joining, then separating, and that this rhythm is what life is. And to that degree that we can synchronize our rhythms and the opening and closing of our personal, quote, gap junctions, we can join with each other to do amazing things that we cannot do alone. Thank you. Please get back to me if you have any responses to this or just any feedback at my website if you want, charlieswenson.com, at my email if you want, the letter c.robert.swenson@gmail.com, or wherever you listen to the podcast. Thank you. Bye.